Hello and welcome back to Exam 1 Review Calc 3. It's terrible. Anyway, so we have Exam 1, which is on chapters 13 and 14. So chapters 13 and 14, 10 questions. They're all about, 10 points. There might be some questions that are 12 and others that are 8, but, maybe 1 or 2. But mainly 10 questions, 10 points each. As I said, maybe in one case you'll have 12 and 8 to make. About 80 minutes, so you guys can come in early if you have any additional extra questions. Now, Exam 1, we haven't learned any new calculus. We start learning new calculus in chapters 15 and 16 when you learn partial derivatives and later on triple integration. That will be kind of new calculus. What you have in this first, you saw a whole bunch of recycled concepts from Calculus 1 that are just bumped into the 3D realm. So technically your first exam boils down to being able to integrate basic stuff and then memorize a whole bunch of formulas. That's your first exam. Do you know all the formulas? So memorizing those formulas is crucial. Other than that, you just need to be able to do basic integrals, U sub, whole bunch of E integrals, sine and cosine basic integrals, polynomial integrals, derivatives. One sad part is, if there is a derivative that involves ln and you don't know how to do it, even though it's second easiest, right? So those are the parts that, in sense that Calc 3 exam is very, very easy if you understand what's going on. So now, the topics that are covered in the exam are the ones that we covered in class. That is, so let's just go to the list of topics. So R2 and R3 vector calculations. Number 2, dot and cross products. So that's another one. Then we have the lines and planes in R3. Number 4, quadratic surfaces. Number 5, vector valued functions. Number 6, calculus with K's. Calculus of vector valued functions. By the way, this is my trademark to write calculus with K's. You will always recognize my notes, right? If you see calculus spelled with K's. That's my trademark. So we have the vector valued functions, and then finally, after that, now motion in space is the vector valued functions again. So this is, okay, fine. Motion in space, even though it should be under 6. Number 8, length of curves. Number 9, curvature. And number 10, normal vectors. As just a principal unit normal vector. Now, where do we learn? I think it's here. I'll write it in blood. t hat, k of t, n hat, length of curves, we have rectangular, we have parametric, and polar, three forms. Motion in space is just s of t, so this is s of t, v of t, a of t. Vector valued functions, there's just r of t as a vector. Quadratic surfaces is multiple choice. All right, so for this one, I am going to give you a shape and 4 equations, and you have to pick correctly, and then I'm going to do it different, right? The opposite. So the question will have part A and part B. You will have a shape and 4 equations, and then equation and 4 shapes. So it's not going to be like in a book, 6 equations and 6 or 8 and 8, whatever they had. It's the bad one because you either circle it correctly for 5 points or incorrectly for 0 points. Then no partial credit on. And I was thinking, you know, if I have a shape that it's kind of close to another shape, and then if you choose the wrong one, then can be a partial credit. But then I went away with that because that's just me technically making you make a mistake, because they put 2 shapes that are similar, and one is at 4, the other one is at 0, and the equation is +4. Well, clearly it's the one that it's at 4. They're the same shape, but it's just shifted. I don't like that. So there will be no partial credit on this one question, which is either 100% correct or 100% wrong. Lines in space, lines are linear. Do not have any x squares, y squares, any of that stuff, guys. You only are allowed to have x, y, z. That's it. X, y, z. X, y, z, no squares. Dot product. This is not just a dot product, also angle. Between vectors. And then R2, R3 calculations. Are you able to add and subtract vectors? Are you able to scale vectors by multiplying a number? Can you find a unit vector? Right? So that's another one of these. So I think this is it on the list. Now look at this. Wow, the list has 10. Now, is it gonna go like this? Obviously not. There is, let's say, for number 1, you will get some calculation with vectors, something that you will probably just gonna fly through. Number 2, well, that's a lot. I can put 4 problems in number 2, right? Just ask for dot product, but dot product can be nicely combined with the angle or projection, so that doesn't have to be a plain dot product. Dot product can be the part of something. We also know a high probability question is if I give you 2 vectors or 3 points to come up with the equation of the plane, right? You have to use cross product to come up with a normal vector. Otherwise, right, that's the ABC vector for the plane. So the cross product, so see how the dot product kind of covers, it can cover multiple, the cross product can cover that, and then planes from here. The line, you have to know the formula, right? Then you have the fixed point, the x0, y0, z0. Plane has it too. Quadratic surfaces, I already said, it's a multiple choice question where you either pick correct or you don't. Vector valued function, that's the R. We saw in the class how the 3 parametric equations that describe the line can be placed into what we call a row vector, and that creates actually just a vector of 3 components, which is, we call it vector valued function. And we don't have to just have straight lines. We dealt with helix and slinky and some other stuff. So anything that you get, it doesn't have to be 3 right? Could be 2 as well. So 2D or 3D. That's a good. And then calculus, remember the only thing you have to remember for calculus of vector valued functions is that you are applying these things component-wise, which means whether you have the limit, derivative, or integral, each component of the vector, if it's a 3D vector, you have 3 components, each one of them gets its own limit, its own integral, its own derivative, right? You just do one at a time. So it's technically 4, over here, for number 6, you have 3 calculus 1 problems in one, right? The procedure to find a plus C for integration, because that would give us something if we do the motion in space. Motion in space, we know we are starting with the position, then differentiate into velocity, then differentiate into acceleration. If you're starting with acceleration, you integrate into velocity and then integrate into. Maybe, let me just draw that. So this is from 7, blue. Clarification on 7. So if you have S of t, which is a vector, and then you have a V of t, which is a vector, and then A of t, which is a vector. So you go differentiate d dt to go down, and you integrate to go up. So in the past, I like to kind of give the velocity, and then you have to integrate one way, differentiate the other way. But I can change that. At least the exam is tomorrow, so I have plenty of time. Right. Know all 3 formulas. This one is in Calc 2, and then 2 new ones from to calculate length of curve. And then finally, know the formula for curvature and know the formula for normal vector. Now, what is the problem that you definitely do last? Well, which problem you definitely do last? The longest one. Which one? What is the most annoying calculation on the list? Normal vector, exactly. So, not if, but when you see a normal vector, right, you leave that one, because normal vector might appear on page 2. You don't want to do that, right? So normal vector is to be done last. Great. What else is in this bag of horrible, terrible calculations that make our curvature? Thank you. Curvature is another one. Vector value. Well, depends on intervals and stuff like that. So definitely, guys, the last 3, 8, 9, and 10, tend to be the lengthiest in terms of calculations, and those are to be done last, no matter which page of the exam they show on. Everything else should be quick, depending on how good you are with the cross product. That could be also, if you have to write everything out, if you haven't figured out how to solve the cross product just by looking at it yet, you have to write stuff down, then that might be longer and lengthier calculation as well. Everything else should go extremely quick. Test taking skill 101, should be telling this in Calc 3 class. But you read the entire exam first before you do anything. Well, you put your name on the test and you claim the paper, right? You put your name on the test and then you put the pen down and read the whole exam first to make sure that all of the concepts that you can do like this are done first. The idea is to have half of the test done in first 20 minutes of the exam, because it can be done if you are, if you have good knowledge and of the material. You should be able to do half of the test in the first 20 minutes of the, even faster than that, because think about it, right? A question might ask you for angle between 2 vectors, right? Of course, you know the formula. You can just fly through that stuff, provide your answer in degrees, and you are done, right? So calculating angle between, oh yeah, don't forget to bring the calculator that can compute angle in degrees and stuff like that. So scientific, no graphing calculators allowed on the test. All right, so in the first 20 minutes, you can literally be done with a half of the test because you just know. And then you can spend another hour or another, right, 5 questions. And that is a lot of time. 12 minutes per question, that's a long time. You have time to mess up and erase and change it and figure out. So, right, if you do the test exactly the one, if you go on a page 1 and you see the normal vector on a page 1 and you keep messing up and you keep getting stuck and you waste, 40, 45 minutes on the first page, you still have 9. Anxiety kicks in and all this stuff and it just makes it worse. So go through the whole test and pick out, right, you'll have that, hopefully, maybe, multiple choice question, right, to pick the shape and all that kind of stuff. So there's a lot of stuff that you guys can do very, very quickly to solve this. And yeah, that's all I have to say. Make sure you have your calculator to calculate the angle in degrees between 2 vectors. I can also ask for angle between 2 planes, right? We know how to calculate that, do we? How do we calculate angle between 2 planes? Yes? Beautiful. Calculate the angle between 2 normal vectors. That's a very straightforward calculation. You see two planes. You immediately see their normal vectors because those are the numbers in front of x, y, and z. Whatever numbers you have in front of x, y, and z, those are your normal vectors. So you immediately have 2 vectors, and you just find, using the dot product, you find the angle between those 2 vectors. It's the same as the angle between 2 planes. Great. Yes?
For us, I know that we have to have the 17 properties for honor doctrine.
Well, the proofs. So I will give you the property, and you just need to write the proof, right?
Oh, so you don't have to, that's something.
Well, the properties are, basic properties of numbers and anything else. But yeah, it will be given. So it's not going to be named. It will be given. It will say prove, and then it has a formula. In that case, you can use 2D or 3D, depending on what you have, right? You guys, so for honors, how many people are going to take the honors test tomorrow? Touch the ceiling. Touch the ceiling. So I have 4. Okay. All right, so then you guys, you have derivation for a plane, derivation for a line, and those derivations from rectangular into parametric and polar. So there are, all of the proofs are very quick, very easy. I used to have more, but then I removed some of them because it got to the point where it was too much to keep track. I also had how to change from arc parametrization into T parametrization for curvature and normal value. It's just too much.
So there's
so you have, well, those first that you labeled 17, they're all one and the same, right? So technically that's all one. Where you replace the vector with, let's say u1, u2, and vector v with v1, v2, and you just run the calculation. So all of those, but make sure that the left is equal to the right. And I did few examples in the notes, right? And then you have, on top of that, derive the equation of the plane, right? That was that image that added 3 vectors. And then derive the equation of the plane where you do the dot product is 0, right? The normal vector and the vector in the plane. You do the dot product and it's 0. So that would, so those 2. So technically you have 4, because all of the vectors are the same. It's just different cases, but it's like the same concept. And then you have the plane, and then you have the line, and the last one is the length of curves to jump. Right, you just multiply by dt over dt and run the calculation inside the square root, and that's it. So those are the 4. Any other questions, concerns? Your lab is due tomorrow, so make sure you finish it today so you can hand in tomorrow. As you walk in, the lab reports go in the corner of the desk. Yes? Yeah, that's the part. Don't worry about that. So projection might be on the exam as the application of the dot product. For the dot product, we either have a work or projection that we did as the example. So both of those are very quick formulas that use dot product, right? So for the projection, obviously the vector u and v will be given, and you just run the formula which you remembered. If you are dealing with forces, then the force vector, the distance vector are given, right? So force times the distance is going to be the work. And I already encountered a few of you overthinking the problem that had the work in the, and I love it, that has work in the lab, where, and these are independent groups that came to me and asked me, okay, so if you look at it this way, it's this number, and if you look at it this way, it's this number. And only one of those two is correct. So just don't overthink those things, and you should be fine. The work has to be done in line. So that's that. All right. So what else? So that's the answer for the scalar is right. Well, polar form is used for the arc length when you have a polar equation. For instance, if you want to calculate the length of the path on a spiral, right? You can come up with the is it theta equals r? Gives us, I think, r equals theta would be a spiral. Let me quickly verify that. Graph r equal theta yes, r equals theta is going to give you the spiral. And if you want to calculate the length along the spiral from the origin where the spiral starts, because theta is 0 and r is 0, so your first point is at the origin. So r equals theta would be a spiral. There is no other way you can calculate the length of that curve other than using the polar arc length. And the polar arc length is just the square root of function squared plus the function derivative, right? Squared. So you can quickly come up with that one. So the polar one would be used for polar curves that you cannot express in the xy realm. Now, xy realm has xy that you used to, and it also has parametric one, which is what you guys maybe learned or not learned. Any other questions? Yes?
For the vector value functions with the Helix and stuff, will you have to like graph those by hand, or is that more like an identifying thing?
Well, you're giving me a great idea, thank you. We learned that whatever that sine and cosine are not, that's where it wraps. And we know that if it's a t, it's a linear rise, t squared goes faster, e to the t goes really fast. And if it's just a number, then it's just a disk, right? It's a circle that it's not on the plane. So yeah, that's a good question to. I might consider adding that. Slinky is too much to draw, right? So a lot of this stuff, I mean, computer generated. So yeah. Any other questions, concerns? Yes.
We don't have to like write out any like formal definitions or questions.
Definition of a vector valued function might pop up, but I did promise you for the second exam I promise you definitely that you will have. For the second exam, definition of a multivariable function, on definition for continuity. So for the second exam, you might have. Right now, you might, because there's just so many formulas, right? We don't have any crucial definitions that you can't live without. Like multivariable function definition is something you can't live without, so that's going to definitely be on a second exam. Continuity is something that is very important for later on in mathematics, so sure, that's going to show up again on a second exam. On the first exam, I really can't pinpoint anything that would be of that crazy importance. So, there's that part. None of the stuff we covered from 15 is on the test, right? So domain and multivariable function and definition and the limits, like the two paths, like none of that stuff is, unless you want it. No? Just check. All right. Any other questions, concerns regarding the test? No? Wow. Good. Yes?
Okay, so on the study plan, there are like questions with like the lines where it was like, oh, find a line that's like perpendicular or skewed on this line. Is there any questions like that? Or is it just straightforward like this one?
Well, again, that's a possibility. Anything that has to do with the line piercing the plane, two lines intersecting, or anything like that, that's all okay, because you know that two parallel lines have to have the same vector v, by same direction of the vector, right? So if vector v between two lines is the same, and we did talk about it in class, I remember. And then for perpendicular or orthogonal, the dot product between two vectors v needs to be 0. And then if neither of those is true, then it's a skew, right? So it's not a big deal. And I remember writing those in blue. So yes, those problems are just fine. There is no, so asking if the line pierces through the plane, and if it does, at what point? Because the line can be parallel to the plane, right? We can if you take a look at this, right, the line down, right, that line is parallel to walls, right? So it's not, they're not going to intersect. So there are a whole bunch of those. And I did say, I remember in class, that I can't do every flavor of the problem because it's impossible, but if you know concepts, you'll know immediately where to plug the t to figure out the value, the point, and so on. Yes?
Will there be like any crazy problem that like mixes in concepts?
Possibly.
Like, okay, because like on the quiz there was like one question where it's like asking like trajectory, and it asked for like the t hat and like the normal vector of like the acceleration of that trajectory.
Well, we did do that in class. We did it with 2D, right? Because you have your vector r, which is the path on which the bug is. I used the bug in class. And then you calculate the t hat, which shows the trajectory of the velocity vector. And if I did it with a car. Remember when I said that there is a curve and that there is a mixture of oil and rain and leaves, and then the car would split out and it would go tangential, right? So you can calculate all of those things. Okay. And I did a circle. So the concepts are not, it's something that we covered, right? And that should count on the easier side. Yes, the normal vector is crazy in the calculation, so it's not going to show up in a problem where you have to, solve one problem that it's 3 hours, right? Generally, I keep the normal vector in its own problem and curvature in its own problem. So you're not going to see a problem that is that long and intensive. Okay. Now, obviously, when you're at home and you're doing these things because you love them, you have time to solve a crazy problem on MyMathLab. But on the exam, we are generally shooting for something that it's sweet, short, right? So if the problem is not one of the last three, right? If the problem is not one of the last three and it's taking you a page of doing something terribly wrong, right? Okay. Because the integration parts and all these things, they should be basic or U sub at worst. I know there was a request for integration by parts, but as I say, you can wait a little bit. We'll see. Anything else? Yes. The word problems are generally related to force of some kind, like work or a force or something like that. So should not be issue. You had a few of them in class, and there was another one on the one that you can't get right. You make up your mind on the lab, right? So that's kind of stuff that nothing too crazy, because guys, you have the physics courses, you have the engineering courses, you'll enjoy, and they are 100% word problems. You'll enjoy all that stuff there. My case over here, I just need to make sure that you know the lowest level over here, which is calculating those problems. Now, figuring out all the cool and interesting stuff, unfortunately, is not here. So, to figure out the situations like this, when you have to apply this in physics 3 or surface potential or something like, then if you don't know Calc 3, calculate will sleep. But or later on, if anyone has to think thermodynamics, anyone? Yeah, right. You'll see the use for Calc 3. You'll be making a lot of money. Anything else? All right. Keep practicing.